NASA admits defeat. China's moon-based tech breakthrough. Imagine looking up at the night sky, knowing that humanity's next great leap isn't just a dream anymore. It's a blueprint. A blueprint being built not by the West, but by the East. In the silent vacuum of space, a new race is being won. Not with flags, but with bricks made from lunar dust. And the implications. They're staggering. What if we told you that the foundation for a permanent human presence on the moon is already being laid not in 2030, not in 2040, but potentially as early as 2026? And what if the leading space agency of the past half-century, NASA, has quietly acknowledged it's falling behind? Welcome everyone to Revo Now, where we decode tomorrow's hidden tech landscape today. Today, we're diving into a development so significant, it could redefine the very concept of space exploration and geopolitical power. Stick around, because what you're about to learn might just change how you see the future of our species. The question isn't just if China will establish a moon base, the question is when, and more importantly, how they're doing it so fast. There's a specific technological breakthrough happening right now that could make their lunar ambitions not just possible, but inevitable. At Revo Now, we look past the headlines, into the silent revolutions shaping our future. Today, we're not just talking about space exploration. We're talking about the future of technology, international relations, and human survival beyond Earth. By the end of this video, you'll understand a critical shift happening in space, one that could impact everything from resource control to scientific advancement. This isn't science fiction, this is the future being built today. For decades, NASA has been the undisputed leader in space exploration. The Apollo missions, the Space Shuttle, the International Space Station, these are the milestones etched into history. Currently, NASA's focus is the Artemis program, aiming to return humans to the moon. Artemis is ambitious. Artemis II plans to take astronauts around the moon. But here's the catch. Timelines keep slipping. Artemis II, initially targeted for late 2024, faced delays. Then, it was pushed to September 2025. Now, the latest official target is April 2026. And Artemis III, the mission to actually land astronauts on the lunar surface, originally slated for 2026, has been delayed again, now expected no earlier than mid-2027. These delays are due to critical technical issues, like heat shield damage found on the uncrewed Orion capsule. Meanwhile, the pace of innovation in space tech globally is accelerating. We've seen incredible advancements in reusable rockets, satellite constellations, and even private space ventures. But what you're not hearing much about in Western media is the rapid, systematic progress China is making towards a very different goal, a permanent, self-sustaining lunar base. China's space program has been methodical. Chang'e 4 made the first ever soft landing on the moon's far side. Chang'e 5 successfully returned lunar samples, and Chang'e 6 recently brought back the world's first samples collected from the moon's far side. These missions showcase their growing capabilities. They're even sharing these samples with international scientists, building goodwill and collaboration. But this is just the beginning of their long-term strategy. China's approach isn't just about landing astronauts, it's about they've already achieved significant milestones. They've landed on the far side and returned samples from both the near and far sides. And they're sharing these samples with international scientists, building goodwill and collaboration. But here's where it gets interesting. China has unveiled its first ever dedicated space science development program, outlining a clear roadmap. The goal: an International Lunar Research Station, ILRS. This isn't just a temporary outpost, it's a long-term habitat designed for sustained human presence and scientific research. And they're not just planning it, they're building the literal foundation. What you're not hearing enough about is their groundbreaking work on. Chinese scientists have developed a solar-powered machine that can turn lunar soil regolith into construction bricks. The first of these lunar bricks is expected to return to Earth by the end of 2025 for testing. This isn't theoretical, it's practical engineering happening now. They're even testing simulated lunar bricks in space. This is the hidden development, turning the moon's own material into the building blocks for its future cities. Their roadmap is clear. Following the successful Chang'e 5 and 6 missions, Chang'e 7 will scout the lunar South Pole for resources. Then comes Chang'e 8, scheduled for launch around 2028, which will carry out experiments on lunar resource utilization and lay the groundwork for the construction of a permanent manned lunar base. But the groundwork, the bricks, the technology, the vision, is being laid much earlier than NASA's current trajectory. China is investing heavily in the development of advanced technologies, including in situ resource utilization, life support systems, and 3D printing for construction. Furthermore, they are exploring concepts like bioregenerative life support systems to ensure long-term sustainability. This comprehensive approach, from sample return to resource scouting to construction technology to life support, represents a cohesive strategy for permanent lunar habitation. Let's talk about speed. Compare the traditional cycle of space missions, often spanning a decade or more, to the rapid-fire advancements we see today. AI is accelerating discovery, manufacturing techniques are evolving, and in space, the timeline compression is real. If we've gone from Chang'e 4's far-side landing in 2019 to actively testing lunar construction materials by 2024 to 2025 and planning for major construction missions by 2028 to 2029, the pace is breathtaking. Consider this. NASA's Artemis program, despite immense resources, is grappling with delays stretching into 2027. China's ILRS program, while collaborative, is moving with a focused, systematic acceleration that's hard to ignore. They are leveraging in situ resources on the moon to maximize living off the land by building lunar bases from in situ material. Autonomous systems, potentially AI-driven, are likely playing a role in streamlining development and mission planning. The ability to rapidly prototype, test, and iterate using lunar resources directly on the moon represents a paradigm shift. It's not just about going to the moon anymore, it's about there, efficiently and permanently. If this acceleration continues, the gap between ambition and reality closes faster than anyone predicted. The focus on ISRU techniques, including low-temperature methods for small-scale processing, shows a practical, near-term feasibility approach. Additionally, the ILRS is designed as an international effort, potentially accelerating development through shared expertise and resources. This collaborative model contrasts with the sometimes insular nature of national space programs, adding another layer to their strategic acceleration. So, where does this leave NASA? The Artemis delays are public. The focus is on a single landing, a single mission. China's plan is broader: a research station, international collaboration, and, crucially, the infrastructure to support it. There's a growing sense that the goalposts are shifting. Think about the implications. A permanent moon base isn't just a scientific outpost, it's a strategic asset. It's a hub for deep space exploration. It's a potential source of rare minerals. It's a symbol of technological prowess and national capability. The technology to build it using lunar resources, that's the key. And China is demonstrably ahead in this specific, crucial area. We're getting closer to the real reason this tech is being developed so rapidly. It's not just about science, it's about securing a dominant position in the next frontier. There's one more piece you need to understand the scale of ambition. China has talked about launching its moon base mission as early as 2026, potentially equipped with its own wireless network. This isn't just a base, it's a connected, operational facility. The groundwork, the bricks, the life support systems like the Lunar Palace concept, is being laid now. In exactly a few minutes, I'll tell you the specific technological breakthrough that makes this 2026 timeline plausible. Recent high-level discussions, like the 759th Xiangshan Science Conference held in December 2024, focused specifically on lunar-based comprehensive space environment platform construction. This signals a concentrated effort and high-level planning for a comprehensive lunar presence. They are even considering ambitious infrastructure like a nuclear power plant on the moon's surface as part of the Chang'e 8 mission, highlighting the scale of their long-term vision. The international community is watching. While collaboration is part of the plan, the speed and focus of China's efforts raise questions about the future dynamics of space exploration. Are other nations, including the US, underestimating the strategic importance of mastering ISRU and lunar construction? The groundwork is being laid now, not just for a base, but for potential dominance in the lunar environment. The breakthrough? It's the successful development and testing of technology. Specifically, the ability to manufacture structural materials directly from lunar soil using solar power. This isn't science fiction anymore. Chinese scientists have built a machine that uses the sun's energy to process raw lunar regolith into usable construction bricks. This means they don't need to launch vast quantities of building materials from Earth, one of the biggest logistical and cost barriers to lunar habitation. They can build using the moon itself. This ISRU technique is crucial for the construction of roads, launch, trial landing pads, dust-free zones, foundations, blast protection, and radiation shielding on the lunar surface. This ISRU technology, combined with concepts like advanced life support systems, creates a self-sustaining loop. They mine the soil, make bricks, build structures, grow food, recycle air and water. This technological suite directly supports the ambitious timeline for a functional base. The project involves multiple international partners, indicating a serious, long-term commitment. Optimistically, this technology could revolutionize space exploration. It makes permanent off-world colonies feasible, opens up vast new resources, and pushes humanity further into the cosmos, faster than ever before. It's a leap towards a truly multiplanetary future. It advances technologies for the collection, processing, storing, and use of material found or manufactured on the moon. But here's the cautionary side. Who controls this technology controls the moon. The nation or consortium that masters ISRU gains an enormous strategic advantage. It could lead to a new kind of space colonialism, where resource-rich areas of the moon become contested zones. It shifts the balance of power not just on Earth, but in space. And the speed at which China is advancing this specific technology is what makes observers take notice and potentially worry. Subsequently, ISRU incorporates the extraction of these lunar resources to reduce reliance on Earth's resources. Now that you know, it's your turn to weigh in. Is this humanity's next great leap? A collaborative effort to build a new home among the stars? Or is it the beginning of a new kind of space race, one defined by resource control and strategic dominance? Should the international community accelerate its own ISRU programs? Should we push for stronger international treaties governing lunar resources? Or should we embrace this acceleration wherever it comes from as a necessary step for our species' survival? Should NASA pivot its strategy to compete directly with China's ISRU focus, or double down on its current human landing system approach? This isn't just about tech, it's about who controls. It's about the silent revolutions happening not in boardrooms or capitals, but in labs, in space, and on the surface of the moon itself. You, the viewer, are now part of the few who understand the scale of this shift. The implications extend far beyond national pride. They touch on the future of science, economics, and even warfare in space. So, what do you think? Drop your thoughts in the comments below. Do you think this ISRU breakthrough will fundamentally change the trajectory of space exploration? What are the ethical considerations of building permanent structures on the moon? Like this video if it opened your eyes to this hidden revolution, and subscribe to Revo now for more deep dives into the technologies reshaping our world and beyond. Thanks for watching. This is Revo Now, decoding tomorrow's hidden tech landscape today.